Hello everyone. In this video lecture, we are going to solve revision questions from Oxford General Navigation book. We will find these questions, some 180 questions, in the last pages of Oxford Gen Nav book. These questions are mixture of all the chapters in this Oxford Gen Nav book. We are going to solve each and every question with detailed elaboration, explanation, tips, tricks, etc. So let's start with question number 1 of this chapter. Pressure altitude is 28,000 feet. Outside temperature is minus 45 Celsius. Mach number 0.46. Winds, track, what is drift and ground speed. So now to find ground speed, you need to know true airspeed. Now you all know that Mach number equals to true airspeed divided by local speed of sound, where local speed of sound is equal to 39.17 into temperature root of temperature in kelvins. Mach number in this question is 0.46, true airspeed unknown, local speed of sound 39.17, square root of temperature. Now here temperature is minus 45 Celsius. Convert that into kelvins, you will add plus 273. So minus 45 plus 273 is 228 Kelvin. So root of 228. So true airspeed will be 0.46 into 39.17 into root of 228. So 0.46 into 39.17 is 18 into root of 28. 228 is 15. So 18 into 15 is 270. So your true airspeed is 270 knots. Okay. Next step is using CX3. True course is 200. Wind speed and wind direction are 270 at 85. So true heading is 217 and ground speed is 228.84, approximately 229 knots. So ground speed is 229 and heading is 217. Heading is 217 true. Now drift. Heading is 217, track is 200. Now whenever heading is more than track, you experience port drift or left drift. Okay. So correct option will be option between alpha and Charlie. Now what is drift here? 217 minus 200 is 17 degrees. So you're experiencing 17 degree port drift. Okay. And ground speed is how much? 229. So approximately 228 knots. So the correct option will be option Charlie. Okay. Now you can find true airspeed using CX3 directly. I've showed you how to find it using formula. You can use CX3 and find true airspeed. Substitute in the wind correction option. All the values substituted, you will get ground speed and port drift of 17 degree. Next, question number 2. Ground speed is there, distance is there, what is time? So time is equal to distance divided by speed, 530 divided by 240, which is equal to 2 hours 12 minutes. 2 hours 12 minutes. So option D is the correct option. Next, ISA deviation plus 30, that is warmer than ISA by 30 degrees Celsius. Pressure altitude is there. What is true altitude? Now to find true altitude, you have to apply temperature correction here. We know that I have made a detailed video also on altimetry errors. Watch that. Watch the altimetry questions I have solved from Oxford as well as BALI. From that you will come to know what I am going to talk now. So true altitude, to find true altitude you apply temperature correction and atmospheric pressure correction. In this case, we are only going to apply temperature correction because we have information only related to that. Pressure altitude is given to us 5000 feet. Now temperature correction formula is ISA deviation into 4 into per 1000 feet. So ISA deviation is plus 30,000 feet. So there is 5000 feet. So 5000. So you just write into 5. Now 30 into 4 into 5 is 600. Okay. So temperature correction is 600 plus 600. That means you are going to add this correction or this compensation value to your pressure altitude. So therefore pressure altitude will be equal to true altitude will be equal to pressure altitude plus correction. Pressure altitude is 5000, correction will be 600. So true altitude will be 5600 feet. Option Bravo. Also remember ISA deviation is plus 30, means it is warmer than ISA by 30 degree Celsius, right? So whenever you fly from an ISA temperature, that is an ISA air mass into an air mass, a different air mass which is warmer than ISA conditions. Okay, so when you fly into a warmer air mass, your true altitude is always more than indicated altitude or pressure altitude. Okay, so your altimeter may indicate or may show 5000 feet, but actual altitude you're flying will be more than 5000. Your true altitude will be more than 5000, 6000, 7000, so on and so forth. Okay, so but just by looking at ISA deviation, you will be able to eliminate a few options like option A and option Charlie, which are less than pressure altitude 5000 feet. Now remains option Bravo and option Delta. To solve that, you will have to use this formula and get the accurate value. But just to save time, you can easily eliminate options Alpha and Charlie, because when ISA deviation is plus 30, meaning current ambient temperature is more than ISA temperature, you know that true altitude is going to be more than pressure altitude or indicated altitude. Question number 4 now. Course dash speed. What direction will the wind give greatest drift? Now drift meaning crosswind. Now you will get maximum crosswind when the wind is coming at an angle of 90 degree or perpendicular to your flight path, perpendicular to your track, to your runway, etc. Okay, that means if this is your course, point A to point B is your course, the wind should come directly 90 degree. That will give you greatest drift. Drift is nothing but deviation from your course AB, left or right. Okay, so greatest drift will happen when wind is coming directly 90 degree to your intended course, track, route. So in this question, your course is 040. So if this is your course 040, maximum drift will happen when crosswind is coming at any angle, at an angle either 90 degree left or 90 degree right. Now 40 plus 90 is 130. 40 minus 90 is 310. The correct option will be either 310 or 130. Now in this case, you do not have 310 or 130. So we will look at alternative option. Now what is the reverse of course 040? The reverse is 220. The reverse is 220. So let's say you are flying from A to C on a reverse course of 220. In that case, the greatest drift will be produced by a wind coming at 90 degree to your track. Okay, so this okay at 90 degree to your track. So the possible options are 220 minus 90, which is equal to 130. 220 plus 90, which is equal to 310. So possible options are again 310, 130. Okay. Now the closest option is the closest option to 310 is 230, 235, 245. Now our reverse course is 220, right? 220, if winds come from 220 direction, that means you are going to get a direct headwind, a direct headwind. So in that case, drift will be 0 degree. There won't be crosswind. If the wind comes from 230, okay, if the wind comes from 230, so difference between course and wind, that is 230 and 220 is 10 degree. So drift will be 10 degrees. Now, if the wind is coming from 235 degrees, the difference between course 220 and wind 235 will be 15 degrees. If the wind is coming from 245 degree and course is 220 degree, the difference will be 25 degrees, right? So the correct option will be the greatest drift will be produced by a wind coming from 245 degree because the angle between course and wind is maximum at 25 degrees. Course 045, winds 190 at 30, flight level 55, ISA conditions exist, variation 15 degree west, calibrated airspeed 120 knots. What is magnetic heading and ground speed? Okay, what is magnetic heading and ground speed? Now required course is 045 true. Let's convert this into magnetic course. So magnetic course will be 045 plus 15, variation west, magnetic west. So 45 plus 15 is 060. Okay. Winds are 190 at 30. 190 true direction. Winds are reported true. Now 190 plus 15 is 205. So 205 magnetic. So let's substitute these values in CX3 and get it. So we'll get our answer in magnetic. Heading is not given to us. Winds 205 at 30. True airspeed is not given to us, but we have calibrated airspeed 120 knots. So what we will do is we will go back and find airspeed. So calibrated airspeed is 120 knots. Pressure altitude is 5500. Outside temperature is how much? Now outside temperature at flight level 55 in ISA conditions will be 15 minus 2 into 5.5. So 15 minus 11, which is 4. So outside temperature is 4 degrees Celsius. So in these conditions, when outside temperature is 4 Celsius, calibrated airspeed is 120, pressure altitude is 5500, true airspeed will be 130 knots, right? Now we will use this true airspeed of 130 knots in wind correction. So we have 130 knots true airspeed, course 060, heading 068 magnetic, both are magnetic, wind direction 205 magnetic. So in that case ground speed will be 153 knots and magnetic heading will be 068. So the correct answer will be option Bravo. Okay, option Bravo. Next, the closest option is option Bravo. Simple. Aircraft flies a great circle track from 56 north, 70 west, 62 north, 110 east. Okay, so 56 north, 70 west, Bravo, 62 north, 110 east. The total distance traveled is equal to how much? Now look, over here the sum of longitudes is 110 plus 70, which is equal to 180. That means these positions are located on meridian and anti-meridian respectively. So the diagram you are going to draw is this one. So to represent meridian and anti-meridian, you need North Pole. You are looking at the Earth from the North Pole, 180 east and west, 90 east, 90 west. So the first location is at 70 west. The second location is at 110 east. Both are amne samne. So you can see like this. That is meridian, anti-meridian. This is the meridian, let's say. This is the anti-meridian. Okay. So you are going to fly from point A, which is from here. Follow this meridian. Okay. Fly a northerly direction and then enter the opposite hemisphere of the earth from western to eastern hemisphere and now fly southerly direction and go towards 110 degree east, 110 degree east. Okay, so you will be flying across the north pole. That will give you a straight line distance, which is the shortest distance. If you follow any other distance, it will be a long distance, right? Longer distance. So now you have to find great circle distance. So now to find great circle distance, you will have to draw this diagram and now represent latitudes here. Here we represented longitudes to explain the concept. Now to find distance, we represent latitudes. North, 56 north, 70 west, 62 north, 110 east. So now great circle distance will be equal to distance between North Pole and 56 north, that is 90 degree minus 56, plus distance between North Pole and 62 north, that is 90 minus 62. Now 90 minus 56 is 34. 90 minus 62 is 28. So 62 degree. So great circle distance will be equal to difference between latitudes into 60. Now the total difference between these two latitudes is 62 degree into 60. So 62 into 60 is 3720 nautical mile. Simple. Understand the concept. So option A. Okay, convert this nautical mile into kilometers, statute mile for your understanding. Next, question 7. You are flying 090 compass heading. Deviation is there, variation is there. So compass, deviation, magnetic, variation, true. The compass heading is 0, 9 or 0. Deviation is 2 west. Deviation west, compass will be best, meaning compass will be more than magnetic. So magnetic will be less than compass, so 0, 8, 8. Variation is 12 east. Variation east, magnetic is least. So true will be more than magnetic. So 88 plus 12 is 100. Your track 160 knots. You are flying 07 radial 070 outbound, and you have gone 14 miles in 6 minutes. What is wind velocity? Right. So over here you have true heading. Okay, you have heading in true. You have task. 14 nautical miles in 6 minutes will give you ground speed. Ground speed is distance by time. 14 divided by 6 into 60 to convert minutes into hours. So 14 into 60 divided by 6 is 140 knots. Is 140 knots. 140 knot ground speed. Right? So let's use CX3. So 140 knot ground speed. Write 140. True airspeed is 160. True heading is 100. True course. What is your course? You are flying 070 radial outbound. So you are flying away from VOR station on a course or on track of 070. So true course is 070. Now remember, one more thing I want to point out, very important. Radial 070 is magnetic, right? So you're going to use magnetic heading, not true heading. So write magnetic heading 088. Here I have written true heading 100, right heading magnetic because course is magnetic. So write 88. So you get wind speed, you get a wind of 50.92 knots and direction 146. So approximately 146 at 51. So the correct option or the closest option here is option A, 158 at 51 knots. Okay. So pay attention, we converted compass heading into magnetic. We have course 070 magnetic heading. Task ground speed was found from 14 nautical miles in 6 minutes. Next question number 8. Question number 9 correction. The sensitivity of a direct reading magnetic compass is what? It's inversely proportional to horizontal component, wrong. Inversely proportional to vertical and horizontal, wrong. Inversely proportional to vertical, that's right, proportional to horizontal component of the earth. So the correct answer will be option delta. The sensitivity of a direct reading compass is proportional to the horizontal component of the magnetic field of the earth. Remember this. Next, aircraft at position 60 north, 5 degree west, tracks 090 through. So let's draw the longitudinal diagram. You have the North Pole here. So the current position is 5 degree west. Okay, you fly 090, that is you're flying easterly directions. All easterly directions are anti-clockwise. All easterly directions are anti-clockwise. Okay, remember this. So that means this is your initial position, you're flying anti-clockwise. So your new position will be somewhere here, here, or altogether in the next hemisphere, eastern hemisphere. The distance is 315 kilometers. So 315 kilometer is equivalent to 170 nautical miles. 170 nautical miles. Convert kilometers into nautical mile by dividing by 1.85. What will be the new longitude? Okay, so we will have to use Rumline formula, d long in minutes into cos lat. So 170 nautical miles, d long in minutes into cos 60. So d long in minutes will be equal to 170 cos 60 is 0.5 is equal to 340 minutes or 5 degree 40 minutes. So the difference in longitude is 5 degree 40 minutes. Now this difference is how much? 5 degree. The difference between 0 and 5. The next remaining distance will be 40 minutes. So the new position will be 40 minutes east. The total becomes 5 degree plus 40 minutes, 5 degree 40 minutes of difference in longitude. So that means your new position is in the eastern hemisphere, right? So the correct option will be option C, 40 minutes east. Important question, okay, conceptual. So draw the diagram and understand. With this, we come to the end of this lecture in which we have solved the initial questions of this chapter. Practice all these questions that I have done or I have shown you the relevant questions. So watch this video multiple times, practice, then practice one more time without looking for the answers. Do it on your own. Set a timer, set the time limit, and do all these 10 questions within half hour, 20 minutes, 25 minutes. Set your own target and work towards that. So it will increase confidence, increase your speed of thinking, speed of writing, etc. So I wish you all the best. Subscribe to this channel if you haven't yet. Share this video with your friends and like this video lecture. All the best, and I'll see you in the next video lecture.